Hello guys, welcome to Mother Code Academy. As earlier stated, we're going to see how to use while loop to find or to check if a number is a prime number or not. The topic of the day is using while loop to check or to find if a number is a prime number or not. Okay, what we are going to do here, the first thing to do is to check or to know what is a prime number. So by definition, a prime number is a number divisible by 1 and itself, meaning it have two factors. The number have two factors, that is 1 and the number. 1 and the number. So the number has two factors is going to be our greatest concern in this video. So we all know that all integers are divisible by 1. All integers are divisible by 1. And all integers are divisible by themselves. But the main difference that distinguish between a prime number and a non-prime number is that a prime number is divisible by only 1 and itself, while other numbers are divisible by 1 and themselves and some other numbers in between the range. For example, now if you take 6 as example, 6 is divisible by 1 and 6 is divisible by 6. 6 is also divisible by 2. So these two here, the common of these two is what makes 6 not to be a prime number. So let's check another one. Let's try 7 here. So if this number is 7, for example, 7 is divisible by 1 and 7 is divisible by 7, but 7 is not divisible by any number between this range. So this makes 7 to be a prime number because it has only two factors. So we're going to use this as our algorithm. So I know that all numbers are divisible by 1 and themselves. So to check if a number is a prime number, I'm going to check, is the number divisible by 2? How about 3? How about 4? Until I come to one less than that number. If I found no 1, then definitely that number is a prime number. But if I found 1, then the number is not a prime number. I hope my students understand what I'm saying. Okay, let's start now. Firstly, we start by creating a variable. Let's say int number. So cout, enter a number. Cin number. So our user, this part of the code is asking the user to enter a number, and this one accept the number a user enter. Then we create another variable. We say bool is prime equal to, let's say, true. Firstly, we assume that all numbers are prime numbers. Our first assumption is that this is a data type, it's a boolean. It holds a variable that is either true or false. So at the beginning, I assume that all numbers are prime numbers. Okay, then I set my counter, int counter equal to 2, because I'm going to start from 2. Since I know that all numbers are divisible by 1 and all numbers are divisible by themselves, so I'm going to start my counter from 2. All right, then I come to my while loop, the main concern of this video. I said while, open bracket, while counter is less than number, then perform this operation. The reason why I say while counter is less than number, because I want my counter variable to be increasing at every iteration. At every run of this while loop, I want my counter variable to increase from 2 to 3, from 3 to 4, and keep on increasing because I'm checking in between this range. Let's assume our user enter 5. Let's assume our user enter 5 in this place. So computer will check 2. Can 2 enter 5 without remainder? No. Okay. Computer will now increment this counter to 3. Can 3 enter 5 without remainder? Yes. Computer will keep on incrementing. I hope you guys understand. So that is why I say while counter is less than number until counter is now 4. So 4 is less than the number, but 5, if counter reach 5, is no more less than this number. Therefore, our while loop is out of range. So now here I'll come here and I will use if statement. I will nest an if statement inside the while loop. I will now say if my number modulo counter equal to 0, meaning, oh my computer, take the number our user enter. In this case, let's assume 5 divided by the value of our counter, let's assume 2. Is the remainder 0? If the remainder is 0, meaning the number is divisible. Yeah, meaning the number is divisible by 2. If the remainder is 0, meaning there is no remainder. And if there is no remainder, then the number is divisible. But if no, okay, let's say if it is true, then come here. Change the value of this our is prime. Let's copy it, Ctrl C. Let's paste it here. Change the value is true to be false. So this value is now false. So if this happen, we firstly assume that all numbers are prime numbers. But if this scenario here happen, then this is no more a prime number. So if this is not a prime number, then we put break. Break is just to stop the execution. Break is to stop everything. So now here we come. So I can reduce this. Then if this is not true, let's say this is false. No, meaning the number is still a prime number. So our is prime factor is still holding the value true. Then we come to here. We set counter plus plus. If I did not put counter plus plus, this is going to be an infinite loop because at each iteration the value of counter remain as 2. And it is going to cause an error to our program. So I have to increment counter by 1 so that counter can come to a point whereby this execution here will be true or will be false. Okay, so from here now, and that is all. I will come out of my loop here and set if is prime. So, let me start from this. If number equal to 1, or before that, let me just show you something, guys. If is prime, then I'll come here. I'll say see out number is a prime. It's a prime number. Then I'll put else here. Else. So let's just copy this line of code here. Let's paste it here and see. So this is our else. Then we say it's not a prime. It's not a prime number. Okay, so I can put something like this here. I hope I'm even correct. So enter a number. Let's enter 7. 7 is a prime number. Of course, yes, 7 is a prime number. Okay. So let's check a different number. Let's check 6. 6 is not a prime number. Just look from here. 6 is not a prime number. So let me just try to. Okay, now let's try 1. How about 1? Just look here. 1 is a prime number. 1 is not a prime number. So our program showed that 1 is a prime number. And we know that 1 is not a prime number. Do you know why it happens like that? The reason is because our counter starts counting from 2. So since our counter starts counting from 2 and we enter 1, so computer will check, is counter less than number? Is 2 less than 1? 2 is not less than 1. So this is false. Automatically, it's going to jump everything in the while loop. So to correct this program, we're going to come here and we're just going to come here and say, if number equal to 1, then Let's copy this line of code here. Control C. Let's paste it here. So if number is the same thing as 1, number is not a prime number. Then I will put else if, you understand? And then the last part of our else is here. Let me just copy this. This system pause is the one that is causing this trouble here. Okay, now let's try 1. So 1 is not a prime number. Can you see it here? I just highlight the place. 1 is not a prime number, and it's fine. So if you like this video, if you enjoy this video, consider subscribing to our channel. Give this video a thumbs up. Let's meet in the next video. Thank you.